Hey guys, tonight I'm playing again with my Nakamichi 680. I was thinking more about frequency response specifically on the lower speed. If you remember, there was left channel which always had a worse than frequency response than the right channel, and we've seen this on the slow speed. And today I figured out the reason. So the reason was in the tilt of the playback head. So how to tune it up? I used a tape recorded with azimuth, which I set for 15 kilohertz. So I was playing this tape. First of all, you use central skew to find the maximum position on both channels. So because you're adjusting the height of the head versus the tape and traces, like that, right? Then gently pull out this black piece and remove this middle gear and use lower gear and observe like levels on the millivoltmeter or like an NACT 100 analyzer, and slowly turn it up to find like best position when both channels give the maximum. In my case, I get like half decibel less on the right channel, but I gain like 3 decibel on the left channel. So it was significant tilt. And as you remember, I've been replacing this playback head, and I saw that it's not up to 680 standards and cannot record well on the low speeds. But now I can show you. So I tuned all 3 tapes now. I set back levels, set bias, and now on normal and high speed, normal speed and low speed, actually it plays and records pretty nice. So that's we are recording white noise, normal speed. So this is source, this is the tape. Okay, you see, and it's normal tape, and we easily gain 20 kilohertz, 22, no problem, right? Now I'm switching to the lower speed, and you may see that it drops. What I mentioned, that on normal tape we have a slope here around like 3.5 decibels, then like a little bit like higher, about 12 kilohertz, it minus 2 decibels, and then it goes down. But this mostly because of the internal filter. So now I'm switching to the source, and you see the source, it's internal filter which cuts off on 15 kilohertz. Okay, so that's the tape now, minimum difference, and it's normal tape. Okay, now switching back to the normal speed, and you see everything normalized. Okay, let me change tape. Let me install Chrome tape. Normal speed I will use 70 microseconds. Starting recording. What we need to do, we need to adjust azimuth for this tape. Okay, so it's a little bit off. Let me screw it first. Oops. So make sure that it will go far away from its current position. Now put it back. You see the second bright spot is far away from the top level. That's how 680 indicates when azimuth is wrong. So even if I switch to the source, you see it still will be wrong. Okay, so I may add on both channels to have zeros. Now I can tune it up again. You can hear it's adjusting. Oops, it's normalized. Now we have azimuth. Okay, source, tape, source, tape. Good. Now that's where we're recording on the normal speed. So that's the source, and this is the tape. Pretty nice view, I would say. Now switching to the lower speed and 120 here. And here is the slope. You see it records fine. So that's the source. And switching to the tape. You see now both channels record high frequencies fine up to 14 kilohertz type 2 on the lower speed. No issues at all. Now let me set metal tape TDK MA. Switching to the metal, normal speed first. Let me adjust azimuth. Okay, source, tape, good. Let me see. Okay, you see on this tape we have a little bit brighter response because I tune it up for the Sony XR. So this is the source, this is the tape, but a little bit brighter on after 15 kilohertz. And this difference I believe is still not fully in phase, you see. Let me try to adjust it and try to tune it one more time. So see, I'm screwing phase. Okay, and now we'll try to adjust it one more time to make it better. It's adjusting. Okay, now you see, now it's in phase. And now we may see white noise. You see now fully correspond left and right channel, fully equal. Source, tape, 1.5 maybe decibel higher after 16 kilohertz. That's the old difference we have. Switching to the slower speed and 120 microseconds. And that's what we have here on this tape. So it's a source, this tape. Okay, I believe I would adjust my left channel just a little bit more. Somewhere like that. Let me see what we have. Yeah, see, plus 2 decibel probably to the source, yes. On the 12 kilohertz. Okay. And that's the source. Oh, that's tape now. That's the source. See, 7 and tape. We are recording 16 kilohertz on slow speed on TDK MA. And now let's see Sony XR. Let's switch to the normal speed first. And adjust azimuth. You see how big a level on Sony XR, like 3 decibel higher. It says that it's in phase. Let's check. When it's in phase, you see left and right channels have fully correspond to each other. Okay, source, tape, 0 difference. Now switching to the slow speed and 120 microseconds. Okay, that's where my adjustment I did for XR plays. So let me return them back. I trust this tape more. Okay, here. Source and tape. You see, Nakamichi installs the filter on 15 kilohertz. That's why it cuts off. I believe it can do better and can do more on this speed. So that would be it. So you see that normal speed it normalizes. Everything is fine. I hope you will be interested. I hope you remember how to set up playback tilt. For the record tilt, we'll do the same. We start recording 15 kilohertz, find maximum, and then remove the middle gear and find tilt by the lower gear to the maximum level on both channels. And then install this gear back. That's it. Thanks for your attention. Hope you like it.